Alright gang, let's finish up chapter 32 with concept 32.4. New views of animal phylogeny are emerging from molecular data. If you haven't heard me say it already, which I know I've said it 50,000 times already, biology and science in general is constantly changing, constantly evolving, if you want to think of it that way, as we learn new information and we gather new data and we kind of change our models and our ideas and we test out new hypotheses. So we're constantly adding to basically our pile of information that we call science. And of course, with modern technology and the ability to do all the various genetic testing that we have, phylogeny is a whole area of science that we have so much more ability now than we did, say, 50 or certainly 100 years ago. So new views of animal phylogeny are emerging from molecular data. Zoologists recognize about 3 dozen animal phyla, but that's sort of still in flux, and it kind of goes back and forth based on new information that we learn. Phylogenies now combine morphological, which is body plan and shape and that type of thing, molecular and fossil data. We have always sort of used the morphological data, and that's what they used 100 years ago. And then of course now we have a tremendous amount of fossil data and the molecular data, which we did not have access to even say 50 years ago. Current debate in animal systematics has led to the development of multiple hypotheses about the relationship among animal groups, and of course that's what science is all about, is continuing to look at some of the different hypotheses and testing those and working them out and getting a clearer and clearer picture of these various groupings. One hypothesis of animal phylogeny is based on mainly morphological and developmental comparisons. This would be kind of the same sort of methods we've used now for perhaps 200 years. And if you look at it this way, this is a view of animal phylogeny based on morphological and developmental comparisons. You basically get a branching phylogeny that looks like this. And this is probably the one that most people are most common with and the one that's most often used. If you look at molecular data, one hypothesis of animal phylogeny based mainly on molecular data looks slightly different. So if you wanted to compare the two, you could, but you'll find that there are some slight differences between these two. So depending on what you're looking at or what set of data you're looking at, you can kind of divide these different animals in slightly different ways. Points of agreement between the two of them are, number one, all animals share a common ancestor. That's the case no matter how you look at it. Sponges are basal animals. No matter how you look at it, sponges are perhaps the most simple types of animal creatures, so we call them basal, meaning near the base. We have this particular clade called Umatazoa. Umatazoa is a clade of animals with true tissues. So if we back that up, only the sponges do not belong to this clade called Umatazoa. Only the sponges don't have any sort of true tissues. Most animal phyla belong to the clade Bilateria, or Bilateria, which are bilaterians, which we already discussed. So you could come down a little bit further here, and most of the animals we're going to look at are bilaterians. Only a few of them, such as the jellyfish and sea anemones and things like that, have the radial symmetry that we discussed. And then finally, chordates and some other phyla belong to the clade Deuterostomia. So remember we talked about the deuterostomes, and that would include everybody from the starfish down the line here, and that would be the creatures that have the particular type of development that we talked about, where the anus forms first, the blastopore becomes the anus. So only in these more simple creatures do they have the protostome development. So some of the different ways we could divide them, but no matter how we divide them, whether we're using morphology or genetic data, there are some basic points of agreement, and these 5 basic points of agreement apply to either of the 2 ways you could look at them. Progress in resolving bilaterian relationships. If we look at the bilaterian creatures, the morphology-based tree divides bilaterians into 2 clades, the deuterostomes and the protostomes, depending on their embryonic development. And then if we contrast that, recent molecular data indicates maybe we should divide them into 3 separate clades, and they list off the 3 clades there. So basically we have Deuterostomia, I'm not sure how to say this word. I'll have to check on this. It looks like ecdysozoa and Lophotrachozoa. Man, I'm not even going to try. Lophotrachozoa. Man, I would have to look that one up as well. Let's go with Deuterostomia, Ecdysozoa, and Lophotrachozoa. Man, can you imagine if we had our biology exams, oral exams, if you had to actually get up and talk and say all these names? I think I would even fail. So depending on how you look at the bilaterians, you could divide them into 2 groups, or you could divide them into 3 groups. If you divided them into 3 groups, you would have the deuterostomes, and then you would have this group, the second group here, which sheds their exoskeleton through a particular process that you're familiar with many insects. And then this third group has some particular feeding structures that make them unique and different, distinct from some of the others. So there is still, of course, as I keep continuing to say, there's still some up in the air about how you could properly divide out, if you get to the very specifics of how you could divide out the different groups of animals, because that's never going to end. I mean, as we continue to learn more information, we're going to fine-tune our various phylogenies and that type of thing. We're going to go ahead and stop right there. That's as good as we need to know for the moment. I would definitely tell you that you want to go and look at the crash course videos. The last slide here basically says that as we learn more, we're probably going to further develop our phylogenies, which you already know that. The more we learn, the more we're going to change what we know and try to make it as accurate as possible. So be sure and watch the crash course video to find out why you should be very glad you're not a jellyfish, because you're going to find out that jellyfish, they only have a single opening. Their mouth and their anus is the same opening, and that is just not cool. So take a look at the crash course video on animal development. Next chapter we're going to look at some of the diversity of the animals in more specific terms. We're going to start with the invertebrates, which would be some of the more simple perhaps or less complex creatures, but it also includes insects and all sorts of species that you might be familiar with that do have a fair amount of complexity. They just don't have a backbone like you and I. So let's stop right there, and I will pick it back up with the next chapter, with chapter 33. See you soon.